Hello everyone and welcome to Network Playroom. This is the 23rd video in the Christmas calendar series, and in this video we're going to talk about why BGP ignores routes and does not install them into the routing table. And this video is in preparation for the next one when we'll discuss BGP best path selection. So before BGP will install a route into the routing table, or more specifically put it into consideration to be installed into the routing table, certain requirements must be met. So BGP ignores paths for the following conditions. So number one is if the path is marked as not synchronized. Let me write that down first. Path is not synchronized. So if BGP synchronization is enabled, there must be a match for the route in the routing table for an iBGP path to be considered a valid path. So the synchronization rule was created ages ago to prevent routing loops or black holing traffic when BGP was not run on all routers inside an AS. Now let's look at a quick example, which is why I have the diagram on the screen here. So first, let's define the neighborship. So RTC and RTA, so router C and router A, are eBGP peers. And similarly, router D and router B are eBGP peers. And as you can see here, router A and router B are iBGP peers, and BGP is not run on router E. No BGP. So router C here advertises this network to router A, who then advertises it to router B, and who then finally advertises it here to router D. That's why you see these arrows going in these directions, like this. So now, let's say router D here is sending a packet to 170.0.10.10. Actually, it was 10.0. So this guy wants to ping this address, and that address lives here. So what happens is that the packet will be dropped on router E, because router E did not learn this route because it's not running BGP. So the synchronization rule was created for that purpose. So this route would not be installed or advertised further unless it was also learned via IGP. So this route would have had to be learned via IGP before it would have been a valid path, and it could have been used for routing. And that would have prevented the black holing problem, which I just explained, because then our router E would also have known about this route if it was learned via IGP. So that is the synchronization rule. But nowadays, synchronization is not really an issue, and it was actually disabled by default on Cisco IOS Release 12.2 and later. Okay, so the next condition is that the next hop is inaccessible. Next hop is inaccessible. So this is rather straightforward and self-explanatory. So if BGP cannot resolve the next hop IP address. The route is not installed into the routing table. So let's say, for example, in case of router A, it learned this route and the next hop was pointing to this address and it couldn't resolve it for some reason, then that route would not be installed into the routing table. It would not be used to forward traffic. Okay, and then number 3, so the local AS number appears in the AS path, then this route is invalid. So the local AS number appears in AS path. So the AS number list in the AS path attribute works as a loop prevention mechanism, and if a router finds its own AS number in the AS path, it ignores the route, and it will not be used for packet forwarding. So let's look at this example again. So let's say that router A got this route from router C from AS300, but if for some reason it injected a router A's local AS number into the AS path, it would ignore it, because now it should be like this when the route is received from router C, so it contains AS300, but if for some reason it was like this, 300 and 100, for example, and it arrived here on router A, so because of this, because it contained its local AS, sorry, this one, 100, then router A would drop that route. It would not be a valid path. And then number 4, if PGP enforced first AS is enabled and the update does not contain the AS number of the neighbor as the first AS number in the AS path. So this is a little bit tricky to write. So let's see, if BGP enforce first AS is enabled, but the update does not contain the AS number. Let's just put but not correct AS number. I should say correct first AS number. So that's a little bit tricky, but I'm gonna open up another layer so we'll see what that means. I'll have to get rid of some of the information here first though. So let's remove all these. Okay, I hope that's all of it. So this one, let's look at an example. This is a configuration example enforcing the first AS configuration. So here, in the following example, all incoming updates from iBGP peers are examined to ensure that the first AS number in the AS path is the local AS number of the transmitting peer. So updates from the 10.100.0.1 peer will be discarded if the first AS number is not 65,001. So here is the command. The command that enforce first AS. So what BGP is now doing is it knows that this neighbor is in this AS. So it should receive an update that is something like this. So AS path. And then the first one should be 6501. And then anything else after that. But if it would receive an update from that neighbor, let's say AS path, and then 100, and then the correct AS number, and then followed by something else, this is not valid. So this route would not be installed into the routing table. And then finally, the last condition, number 5, is if the route is marked as received only. The route is marked as received only. So this is the case when soft reconfiguration inbound is enabled for the neighbor and the policy has rejected these paths. So the router has stored the rejected paths as received only. Now a quick explanation here. So when or with soft reconfiguration inbound enabled, BGP stores a copy of the received routes, and this copy takes up memory, but it serves a useful purpose. Now, when you apply policy changes to a BGP neighbor, you can run the saved copy of the received routes through the new BGP policy filters. And you can make policy changes all you want, and the BGP neighbor never has to resend you its routing information, and you never have to tear down the BGP session between the BGP peers and disrupt the network communication. So yeah, this is used together with soft reconfiguration inbound. So you receive routes from a neighbor, and some of them are valid paths and are used for routing or are installed into the routing table, and those that are not are marked as received only, and hence they're invalid to be used for packet forwarding. So those are the 5 conditions that prevent a route from being installed into the routing table. So this is kind of the first step before the actual BGP path selection process, which we'll look at in the next video. So thank you again for watching, and I'll see you in the next video.